In one of Belgium's most important industrial cities, somewhere in Charleroi, a massive complex of steel, concrete and rust rises into the skyline. Once one of the key centers of European steel production, this place shaped the life of an entire region for decades. Even today, numerous buildings and structures still stand. Among the vast remains are the relics of massive coke plants, decommissioned power stations and abandoned blast furnaces, rusting witnesses to an industry that once defined everything here. Join us as we explore this massive lost place. The site traces back to the company Forges de la Providence, which established one of the most important ironworks in the region here in the 19th century. Industrial use began as early as the 1830s, and over the decades the site developed into a central hub of iron and later steel production in the Charleroi area. In the past, the entire production chain took place here, from coke production and iron making to steel production. Over time, the facility changed through numerous expansions, company takeovers and partial shutdowns. Despite these developments, steel is still produced here today. In this episode, we explore the coke plant on the site. This is where one of the most important components of steel production was produced. Coke, which was needed in the blast furnaces to first extract pig iron from iron ore. The raw material for coke production was hard coal, which was delivered in large quantities by freight trains and via the canal from the surrounding coal mining regions. The coal was transported via conveyor belts into the large coal bunker, where it was temporarily stored. Coal has different properties depending on its origin and type, such as carbon content, volatile components, and the resulting coke quality. Therefore, the delivered coal was stored separately in the coal bunker according to its type. Using conveyor belts and grab cranes, the different coals were then precisely mixed to create an optimal composition for coke production, the so-called blend.
Ja.
The blended coal was transported via conveyor belts to the crusher building. There, it was first crushed and brought to a uniform particle size. This step was necessary to ensure even compaction and optimal conditions for the subsequent coking process. Afterwards, the prepared coal was transported from here via a long conveyor belt to the upper section of the coal tower, the large building at the rear of the site. In the coal tower, the prepared coal was temporarily stored and evenly distributed to the subsequent processes. From here, it could be fed into the coke ovens in a controlled manner and in precisely measured quantities. This intermediate storage was necessary to ensure continuous operation, as the ovens had to be supplied evenly around the clock, regardless of fluctuations in delivery or processing. Below the coal tower, the prepared coal was discharged into a special charging car, which was once located beneath the tower and ran on rails along the coke ovens. It was filled from above and transported the coal along the oven battery, where it was then loaded into the individual oven chambers. This system allowed for a precise and even distribution of the coal across the entire battery. In the coke ovens, the coal was ultimately converted into coke. It was heated to temperatures of over 1000 degrees Celsius in the absence of oxygen. This process, known as coking, took around 16 to 20 hours, during which volatile components such as gases, tar, and water were released. From a chemical perspective, what remains is primarily nearly pure carbon. This solid porous fuel, coke, is highly heat resistant and in the blast furnace not only provides the necessary energy but also helps remove oxygen from the iron ore. After the coking process, the finished coke was pushed out of the oven chambers by a so-called pusher machine and onto a waiting quenching car. This then transported the glowing hot coke to the quenching tower, which was located to the left of the coal tower. There, the coke was deliberately quenched, usually using large amounts of water. This step was necessary to cool the coke quickly, make it safe to handle, and prevent it from continuing to burn uncontrollably in contact with air. After cooling, the coke was transported via conveyor belts to the screening plant. There, it was sorted by size and separated from fine particles. This step was necessary because a uniform size was crucial for further processing. Only in this way could optimal gas flow and stable operation be ensured. Afterwards, the coke was temporarily stored and then transported via conveyor belts to the nearby blast furnace. During the cooking process, volatile components were released from the coal, including coke oven gas, tar, ammonia, and various chemical compounds. These substances were not simply vented, but were deliberately captured and further processed. A key part of this process was the gas precooler, where the hot coke oven gas was first cooled, allowing initial components such as tar and water to condense out. Liquid byproducts like tar and ammonia-rich water were then stored in large tanks and later processed further. Another byproduct of coke production is the so-called coke oven gas, which was reused directly on site in a massive power plant. In the second episode, we explore this impressive facility with its striking, almost steampunk-like boiler house and enormous turbine hall, learn how the coke oven gas was used, and find out why it is known in the urbex scene as the Blue Power Plant.